Namaste one and all. Let us look at the concept called as electric dipole. So an electric dipole is nothing but a pair of equal and opposite charges minus q and plus q separated by a distance of 2a. So if we consider this as charge minus q, there should be another charge plus q and they have to be separated by a distance, small distance 2a. So then it's called as a dipole. Then the direction of dipole is from minus q to plus q. The center of the dipole is the midpoint between minus q and plus q. So this is the center of the dipole. So if you look over here, they are at a very smaller distance. So if we look away from far away, so the total charge appears to be cancelled out because both are equal and opposite. But the electric field is not zero because there is small amount of distance between minus q and plus q. So then what is the electric field? So let us try to find the electric field along the dipole axis at some distance r, which is greater than a. So a is nothing but the distance between the center of the dipole to the charge. So this distance r should be greater than that of a. So if that is the case, so what is the electric field at this point? So we call this point also as axial point. So the electric field at this axial point is given by 2kp divided by r cube, where p is the dipole moment. We call the p as dipole moment. It is the product of charge q and the distance between the two charges. As you know, the distance between two charges 2a. So it is the product of charge q multiplied by distance between the charges, that is 2a. And r is the distance, as you know, r is the distance from the center of the dipole to the axial point where we are trying to find the electric field. So if r is greater than 2a, what happens is electric field vanishes and it cancels out. So the electric field would be decreasing as the distance increases. It is inversely proportional to 1 by r cube. So E will vanishes or cancels out when r is very much greater than 2a, where 2a is the distance between the two charges. Similarly, if you are trying to find the electric field at a point on the equatorial point, or you can also call this as bisector. So there is nothing but the center of the line joining the 2 point charges. So this is the center, as you know. Along this line, if you are trying to find the electric field, this is called as equatorial point or bisector point. So what is the electric field? So again, it is given by kp divided by r cube, where p is the dipole moment, which is nothing but q cross 2a divided by r cube, where r is the distance from the center of the dipole to the equatorial point where we are trying to find the electric field. So but the direction of this electric field at equatorial point will be exactly opposite to that of the dipole moment direction. So we need to be very observative here. So the direction of this electric field at equatorial point is exactly opposite to that of the direction of dipole moment. The dipole moment direction is from where? Minus q to plus q, that is, it is pointing towards right, whereas the equatorial point electric field is pointing towards left. So and if you observe carefully these two equations, that is electric field at axial point and equatorial point, electric field at equatorial point is exactly half of that of the electric field at axial point. So this is regarding electric dipole. So thank you for watching the video. I hope you have understood the concept. Thank you for watching the video. I hope you have understood the concept. So to know whether you have understood the concepts better, you need to answer the quiz. The link for the quiz is given in the description below. After answering the quiz, you will be getting the result. So retake the quiz until you find that you have answered all the answers correctly and got the complete out of out results.